Hey guys, Kevin here. We're looking at another AIME problem. This one is from the 2002 AIME 2, problem 6, and let's get started. So once again, if you want to open this up in a new tab, feel free to do so. Pause the video if you want, and get to work. Maybe if you want to solve this problem before I attempt to do it, that's totally fine as well. Then you can try to check your answer or see if maybe there's a better method or an alternative way to solve the question later. Your choice. So we have a summation here. We have 1000 times some summation of 1 over n squared minus 4. So one thing I immediately notice, well, apart from the 1000 not really mattering because it's outside of the summation, is that we start from n equals 3. So why do we start from n equals 3? And normally in summation questions you would start at some nice number, n equals 0, n equals 1, even rarely you have n equals 2, but n equals 3 doesn't really appear. It's not really a number you would really go for unless there's something special in it. And in this case, well, n equals 2, if you just plug it in, it gives 1 over 0, which doesn't work. It's undefined. So that's why it's n equals 3. And n less than 2, n equals 1 or n equals 0 makes it negative, which also probably doesn't work for the summation. Oh, I was thinking the wrong way. Makes it undefined. Okay, and we can kind of assume that 10,000 is just some arbitrary number that they picked in order to try to make the answer format pretty nice. Or not nice, depending on how AIME wants to do it. So what do we notice here? So our main focus is on the fraction 1 over n squared minus 4. Now this is important because n squared minus 4 is a difference of squares, and you should definitely notice this when you first see the fraction, that n squared minus 4 can be factored in a difference of squares. This kind of intuition will help you a lot in AIME questions, and knowing what polynomials can be factored or not can often lead to a really elegant solution. So here we have n squared minus 4, it can be factored into n plus 2 times n minus 2. Now, I'm not sure how many of you actually know this, but you can actually factor these expressions, or these like 1 over some polynomial n through the roots. Basically, you're factoring 1 over n squared minus 4 in terms of 1 over n plus 2 and 1 over n minus 2. Now there's a method to do it. It's called like the Harvey-Side cover-up method. But of course, for the purposes of this proof, we'll assume that we don't know this method. So we know that there's some linear combination, though, of 1 over n plus 2 and 1 over n minus 2 that makes 1 over n squared minus 4. So how do we find this linear combination? So what we do is, of course, use some algebra. We have 1 over n squared minus 4 is equal to some a times 1 over n plus 2 plus b times n minus 2. Now here you may be wondering, wait, Kevin, why are you using a and b? A and b don't have to be constants, they can be polynomials as well. Well, yeah, you would be right And maybe you didn't ask that question, but anyways, the problem with, or in this case specifically, a and b have to be constants. And the reason for that is because suppose a and b were not constants, so that they had some n coefficient, or they had some n to the power of something coefficient. Now, what that would mean is that you could essentially factor it out of the fraction. We can basically filter it out of the fraction by just simplifying it, like doing the thing we learned in elementary school, like the improper fraction to a mixed fraction or whatever that was. And essentially you would get something that's outside of the expression. You would get like a c that's outside. And the c can be like a polynomial of n, whatever. But basically, now you have a and b are constants with the c. And notice that c is, of course, does not have to be constant. It can be a polynomial. Now the problem with this now is when we try to condense it, we get a times n minus 2 plus b times n plus 2 plus c times n squared minus 4 squared minus 4. When we try to collapse it like this, the problem is that we assume that c is not equal to 0. And c not equal to 0 means that we have an n squared coefficient in the numerator. So in fact, yes, for some cases you would want a and b to be with linear factors, or with non-constant factors. But in this case, because we have our numerator being 1, we have to have c equals 0. So let's simplify that. We actually have this. Okay. And because of this, we have our equation a times n minus 2 plus b times n plus 2 is equal to 1. And because n is some arbitrary variable, it's always good to find our values a and b in terms of this arbitrary variable, even though we won't need it really here. So we have a plus b, n minus 2a plus 2b is equal to 1. And this is nice because we know that n is arbitrary, so in order for it to be 1 for any value of n, we need a plus b to be 0. And we need this. So this is a system of two equations. We can solve this. So we get a is equal to, plugging it in, you can like double the first equation and add it to the second. So b is like 1/4, and thus a is negative 1/4. And thus we get that our summation, what we want, 1,000. Now we have negative 1/4 and 1/4, so we want to kind of bring the 1/4 out of the summation, of course. Get to that in a second, I guess. N equals 3 to 10,000 of this will be negative 1/4 of 1 over n plus 2 and 1 over 4, 1 over n minus 2. And yes, we can definitely bring this 1/4 outside. So we are left with this. And this becomes 250. now, because we have this, you might find this very familiar. In fact, this is telescoping. And what telescoping means is that we are essentially canceling out fractions when we change the value of n. For example, when n equals 3, the summand is -5 plus 1, and in n equals 7, summand is -9 plus 1/5. And since we're summing everything together, so that means we're adding n equals 3 to n equals 7 somewhere down the line, the -1/5 will cancel out with the 1/5 here. And no other n will give a 1/5 because we know the only fractions that this sum gives is -1/n plus 2 and 1/n minus 2. So effectively, a lot of terms cancel out. In fact, pretty much every single middle term will cancel out, with the exception of a few at the very front, because they can't really be canceled out by the stuff in front of them, and stuff at the very back, which can't be canceled out by the things in front of them. So you'll see what I mean in a second. This is, or basically, notice that the smallest cancellation we can make is basically dependent on the value of -1/n plus 2. And when n equals 3, this is a cancellation factor of -1/5. And thus, every single number, -1/5, 1/6, 1/7, etc., they are canceled out, or up to a certain point. And what this also means is that the stuff before 1/5, so 1/2, 1/3, and 1/4 are not canceled out. And similarly, at the very end, the highest kind of canceled factor that we can have is when n equals 10,000, and in the positive side we have 1/9,998. Stuff after 1/9,998 cannot be canceled out. So this is 9,999, 10,000, 10,001, 10,002 are not canceled out. So these are the only factors that are not canceled out, and thus our summation will become 250. Just copy paste this. Oh, I didn't need to do that. It was just 1 plus 1/2. Okay, I'll add the thing. Plus 1/3 plus 1/4 minus 1/9,999 minus 1/10,000 minus 1/10,001 minus 1/. So we want to find the closest integer to this value, which we can definitely find by just computing everything, and thus we'll do that here. This becomes 250 times 1 plus 1/2 is 3/2, 3/2 plus 1/3 is 9/6, 2/6 is 11/6, and then 22/12 3/12, so that's 25/12. It's 15. And then we're subtracting a bunch of stuff that we're subtracting 4 things that look a lot like 1/10,000. So that is, it's inside. I bet 0. What is 1/10,000? Okay, so 1/10,000 is going to be this, so times 4 is that. And of course you can just check it pretty easily. And our answer will be 6250/12 minus, what is that, 0.004 times 25, so 0.01. Is that what is it? Is that what it is? Or is it actually, oh, it's actually 0.1, okay. Right? Or this is approximately equal. Yeah, it is 0.1, okay. What am I doing? Is equal to, and we can simplify this, so this is 520.8 something, 833, I think, minus 0.1 is equal to like 520.7 ish, and this gives you an answer of 521.